Hello and welcome into the first video for lesson one for Precalculus 1. In this video, we're going to be looking at fractions. We're going to be discussing unions and intersections and interval notation for both of those, as well as looking at absolute value. As with all the video sets for these lessons, there's two videos. The first one, so this one will be just the content portion. So I'll be giving you formulas, be giving you definitions, things of that sort. And then the second video, that will have all of the examples. And it's going to have the examples of the types of problems that you should be familiar with to be successful on the homework that you should be doing before you come to class, the homework you'll be doing in class, and most importantly, the exams. So let's get started. Let me share the document camera. That would be a good idea here. Okay, so what we're going to talk about first with the fractions is our properties of fractions. For the most part, this is the arithmetic that we can do with fractions. The easiest type of arithmetic that we can do is multiplication, because there's not really much thinking that has to go into it from our end. So if, for example, I have A over B times C over D, assuming I can't simplify this at all first, and we'll talk about simplify here in a minute, I'm just going to multiply the numerators and multiply the denominators. So that's it. Don't make it more complicated. Just multiply what's on top, multiply what's on bottom. And again, we call this numerator denominator. The second easiest would be division. And the reason it's the second easiest is because we're going to turn this into a multiplication problem, the easiest type. So you guys have heard of Kentucky Fried Chicken, and now I think it just goes by the letters KFC. We're going to use close to that here. Instead of KFC, we're going to do KCF, which stands for keep, change, and flip. So we're going to keep the original A over B, change it from division to multiplication, and then flip the second one. So instead of C over D, it's now D over C. And now we have what? Now we have a multiplication problem. So multiply the numerators, multiply the denominators. The third type of arithmetic we're going to be doing is addition or subtraction. So if I have A over B plus or minus C over B, well, as long as the denominators are the same, then we're just going to end up with that as our answer for the denominator B, and then it's A plus or minus C, so add or subtract the numerators. In the real world, that rarely happens. Rarely are you going to get, 3/5 plus 7/5. You're not going to get that. Instead, what you're going to end up with, likely, is A over B plus or minus C over D. And so I'm going to show you guys a shortcut method here. So we could convert both of these to have the same denominator and then just apply property number 3 now that they're the same. But a lot of times it's easier to do what I call the cross multiply method. So we are going to first multiply from upper left to lower right. So A times D. And that's important. It has to be this direction first. And we'll see why when we do some examples with the subtraction. And then plus or minus, whatever the sign is in between there. And then we do B and C, go the other way, lower left to upper right. And then multiply the denominators B times D. So let me show you just a quick example. Let's say I have 2/3 plus 4/5. I'm going to multiply upper left to lower right. So 2 times 5 is 10, plus 3 times 4 is 12, and then 3 times 5 is 15. So multiply this way, get 10, multiply this way, get 12, put the plus sign because there's a plus sign, and then multiply the denominators 15. So now simplify, 10 plus 12 is 22 over 15. So it's a little quicker than converting 2/3 to have the same denominator as 4/5. If I convert that denominator, just makes our life a little bit easier, but you have to be careful to go this direction first. We can simplify fractions. So let's say I have A times C over B times C. Well, because I have this common value C, I can cancel that to simply get A over B. Now, what you have to be careful with here, though, is that it's in multiplication. So if there was a plus or minus sign between these, if it was like A plus C and B plus C, then you can't cancel out the C's because that plus or minus has a direct impact on that value. So you can't just cancel it if it's plus or minus, only for multiplication. And then lastly, we'd have cross multiplication. So if A over B equals C over D, then I can cross multiply. A times D is equal to B times C. So that is the properties of fractions. And again, we'll look at a bunch of examples in the second video. So next, I want to talk about union versus intersection. So when we're talking about union, we are talking about all the values from a given sets. And so we'll talk a little bit about that in a minute here. But we basically want all the values that are involved. The notation for this is a big capital U. Intersection. So with union, it was all the values. Intersection is the overlap. So what value is in set A and set B? And that's where you'll sometimes see these words. Union, we're talking about or. Intersection, it's and. So it's in set A and set B. Versus union, where it's in set A or it's in set B. And the notation for intersection is an upside down U. So let's just look at a quick example here. So let's say I have some set M, which has this brace, and maybe it's 1, 2, 3, and N. And when we have these braces, it means just that value. Just 1, just 2, just 3. And you'll see why in a minute when we start talking about our interval notation. And let's say N is 2, 4, and 6. So if I want M union N, it means what value is in M or N? Well, in M, I have 1, 2, and 3. In n, I have 2, which I already wrote down, 4, and 6. So again, it's all the numbers because of union in m or n. But if I want m intersect n, it has to be in both. So do I have a 1 in both? No, I do not. Do I have a 2 in both? Yes, I do. Do I have a 3 in both? No, I do not. So the only value that's in both is 2. So m intersect n is just the value 2. So that's this idea of union or intersection. And what we're going to be using a lot is intersections. When we start talking about domains, we're looking for the intersection of these. And so we're looking for the overlap. Most of the time, and I know in this first set of homeworks, it's just going to have you write things with inequalities. But for the majority of the semester, we're going to be doing what's called interval notation. So what that looks like, so what I should put here is we are going to be using parentheses or brackets. So if on a test, it says write your answer in interval notation, and you do not submit an answer that has parentheses, I should put and or brackets, then your answer is wrong already because it's not an interval notation. So the first type of notation is with parentheses. So I might have something that looks like this, A to B. And these parentheses means not included. So in this case, the A is not included, the B is not included, but everything else in between is included. And so the way we write that on a number line, when I have parentheses and it's not included, it gets an open circle. So that's my notation that, oh, A is not included. B is not included, so it has an open circle, but I connect them with a line. So everything between here is part of this interval notation, but the endpoints, we do not include it. And so what this is similar to is like inequality. If I have like 1 is less than or equal to x, less than or equal to 5, it means all the values between 1 and 5, so 1.1, 1.2, 1.7, 2, 2.5, etc. Everything between 1 and 5, but not including 1 and 5. I have brackets. When I have brackets, it means these values at the end are included. So if we want to think of it in inequality notation, it's everything from 1 through 5, including 1 and including 5. And on a number line, the way this differs is it now gets a closed circle. So we draw a little circle that's filled in, and again, the line between them. We could have a combination of the two. So A has parentheses, B has a bracket, and all this means is that A is an open circle and B is a closed circle with the line between them. And then a sort of special case is when we have infinity. So infinity or negative infinity always gets parentheses. And when we are trying to find intersection or union with interval notation, what we want to do, which will make our life a lot easier, So to find union or intersection with with intervals, I'm going to write this in red. We're going to draw number lines. So when we draw number lines, then we can actually see, okay, where's the overlap or where is the union? What numbers are being covered? All right, and then lastly is our absolute value. And this, by definition, so absolute value describes the distance from 0 on a number line. So because it's talking about distance, this value is always positive. So if I say, how far is Las Vegas from Los Angeles? The answer is, let's say 300 miles. It's not negative 300 miles because I'm going to the west. It's just 300 miles. So the same thing with absolute value. So for example, if I have, oh, and this is the notation. Sorry, let me write that. Notation is like these two vertical bars with some value inside. Let's call it C, some constant C. So one more thing here. So if I have absolute value of C, this is equal to C. So how far from 0 is C on a number line? It's C units. Or similarly, how far is negative C on a number line from 0? It's also C. So if we looked at this graphically, if I have a point C out here, it's a distance of C. If I'm down here on the number line, negative C, it's still a distance of C. Some quick examples. If I have absolute value of 3, well, this is just 3. But if I have like absolute value of negative 10, well, on a number line, here's 0, here's negative 10. How far am I away from 0? Well, I'm 10 units. Therefore, the absolute value of negative 10 is just 10. So that's how we deal with absolute value. And that's it for the first video here. Fractions, union, intersection, interval notation, and absolute value. Check out video 2 for lesson 1. That'll have a bunch of examples and you'll be able to start to see how these different properties and things work, as well as test your skills to see if you have an understanding of it. So thanks for joining, and we'll see you in video 2.